Hi, and welcome to InterSystems Virtual Summit 2020. My name is Benjamin, and in this session, we'll talk a little more about data warehousing and how InterSystems Iris supports these use cases. First, let's take a look at what data warehousing actually is. Consider this environment. So this is a production environment where goods get produced, where they get manipulated by super specialized machinery that kind of manipulates individual goods one at a time, and is all focused on maximizing throughput, on making sure that all of these goods come out at the other end of the conveyor belt in finished shape at the highest possible speed. So this environment may not be where you want your consumers to be nosing around. You may also not want your distributors in this factory floor. You may not even want your accounting people to come in and walk around and take stock. You'll probably be more comfortable with them walking around in an environment like this, where everything is nicely organized, not for production, but for consumption, where everything is stacked up in boxes, on pallets, everything is nicely sorted, and people can quickly find what they're looking for and kind of operate on it in bulk. Just pick up a whole box, pick up a whole pallet, rather than having to manipulate individual goods. So this contrast also exists in the data world. In the previous picture, you saw a production environment. So think about a transactional application where, for example, you're processing payments, or where you have a point of sale application, or pretty much any ERP, enterprise resource planning type of application. We call these OLTP applications, online transaction processing applications. And there's all kinds of specific features that database vendors offer to support those use cases and maximize throughput, maximize the ability of the system to process individual transactions at a high speed. Now, at the other end of the spectrum, we have OLAP style use cases, online analytical processing. That's analytical querying. That's the business intelligence tools, reporting tools, where you want to be able to query possibly large numbers of records in one go in order to aggregate that information, sort it, and get some overview information out of it. That's a whole different type of use case for which there's a whole set of different features, database features that are practical for these use cases. And they're not all mutually exclusive, but some that work really well in one area are not very practical in others. In the same way that the robotic screwdriver is very practical in the previous picture, but it's not very practical to pick up a pile of boxes here. Okay, so that was to kind of set the scene. Now let's take a look at some definition of a data warehouse. I'll try not to bore you to death with the theory here, but data warehousing actually goes back a pretty long time. So in the 70s and 80s, the concept emerged, and in the 90s, Bill Inman and Ralph Kimball made a lot of publications around the topic. And Kimball's definition is really practical because it says just this. It's a copy of your production data. So it's a copy of the data that was in our production environment, but now specifically organized for query and analysis. So it's organized so that your measures, your metrics, the revenue, the number of goods, those metrics can be easily aggregated across dimensions. For example, date, region, product line, etc. So that's Kimball's definition. Inman's definition is actually talks about 4 properties that have a definition each, and he's more talking about an enterprise data warehouse as the single source of truth, and then more data marts to spin out of that, whereas Kimball is a little more pragmatic and just talks about those dimensions and measures as sort of the first emergence or first start of copying your data that can then percolate into an enterprise level data warehouse. Okay, 70s, 80s, 90s, is this all still relevant? Is that concept still relevant? And the answer is obviously yes. People still want to query their data. People still have a need to get access to their data, get that overview out, to be able to present in the boardroom about everything that happened in the environment, how sales went across the different channels and applications that are in use in the environment. So there definitely have been technological evolutions, but the concept of copying your data in a structure that makes it practical to query is definitely still standing. The rise of software as a service has kind of played an interesting role here because when you're thinking about a software as a service, you're probably thinking about some sort of a cloud service, and your data's out there. So you can't simply select from those tables and join that to data that's in your on-premise production application. So that kind of makes it even more pronounced to still need some sort of a data warehouse that allows you to query all of that information together. Whether that's physical or virtual or federated, that's not super important. Conceptually, you still need that place. Conceptually, you still need that data warehouse. So what are the technology evolutions? So there has been this movement around big data, or at least the buzz around big data, where people considered that the volume of data that was emerging, the speed at which that data needed to be ingested, and the variety, the multi-model, the multiple types of data models that in which the data emerged, were impossible to service with classic data warehouse tools. And that is correct. There was a lot of need for technology innovation at that time, but most of those things have been solved at a technical level in the meantime. And now the large data platform vendors, they offer features to deal with these fees, to deal with the classic challenges of data warehousing, all within a single platform. And the new opportunities are perhaps less technical, but more exciting in terms of function and responsibility in a bigger corporate picture. So let's take a look at those: data governance and AI. So data governance is all about trust. If you've heard the term chief data officer, this is his job. It's making sure that consumers across the organization, data consumers across the organization, can trust their information. And because we're talking about data consumers, we're sort of inherently also talking about data warehousing, because that is where people go to query data. So some common features that were traditionally associated with data warehousing are about data quality. Data quality, making sure that your data is trustworthy by itself, that it sort of adheres to the specification, that there's not too much noise on your data, and being able to monitor that and improve that at every step of the way as your data flows from production into consumption data structures. That's what data quality is about. Making sure that you can tie the pieces of information on the OLAP side to the source applications, however fragmented they may be today. That's what data lineage is all about. And that's getting even more complicated, of course, because of that fragmentation of data sources. A semantic layer is a little bit like a data catalog, a place where you can find out more details about your data. So it's all about metadata. And a semantic layer, as we'll see soon, is also very practical for data scientists, who can then sort of browse the catalog and select the features that they think are interesting for the particular data science experiment that they're about to undertake. So semantic layer is about metadata. Then the master data itself, think about your customer data, that's another particular area in the broader umbrella of data governance. So making sure that you manage those golden records properly, that you deduplicate your customers, that's master data management, and that also fits this broader picture. Something that's pretty important, that's also why the Chief Data Officer has a C in his title, is that it's not just about technology. It's not just about picking one particular platform or tool and then be done with it. No, data governance is also about establishing some policies, what people can and cannot do, and processes, and getting all of that into place, and making sure that everybody kind of is on the same page with respect to how to go about the data. That's also part of data governance in general. Okay, machine learning and AI are, of course, very exciting by themselves, but let's look at them in the context of data warehousing. And you can look at ML and AI as a means to do data warehousing, as a tool to implement data warehousing. For example, to make your database smarter, to make your query optimizer smarter by learning from the query statistics of past queries. That's an application of machine learning inside of your data warehouse. Leveraging AI, for example, to do that deduplication of customer records is another use case for AI within data warehousing. And then, of course, there's also using your data warehouse as a source for your machine learning endeavors. Because your data was put in there through some orchestrated process, applying some data governance, you can be pretty sure that the data is already relatively clean or has been curated at least a little bit. So that makes it more dependable training data for your machine learning use case. And data provisioning is a very interesting kind of feature or mechanism. So more and more organizations are kind of setting up a feature library. Think about that data catalog, that semantic layer where they pick from a documented set of pieces of information what data they want to use in their data science environment. Then it is automatically provisioned in sort of a sandbox environment, and then it's taken down again after they finished their experiment. So that data provisioning, that data ops, is emerging as sometimes even a reason all by itself to establish a good data governance practice. We've talked a little bit about data warehousing, what the technology entails, and what kind of opportunities there are within this broader market area. Now let's take a closer look at what you can do for achieving a data warehouse or implementing your data warehouse with InterSystems Iris. And let's ask ourselves the question, why would you choose InterSystems Iris for your data warehousing use cases, for your OLAP use cases? And we'll first start with the hypothesis that you already have an application running there. InterSystems Iris has a strong heritage in operational use cases, in OLTP use cases. We've been recognized by many analysts for this. And so if you want your application to include a couple of analytical features, for example, a little bit of a dashboard on the home page where your application users log in, apply a particular predictive model as part of a business process that's hosted in that's running in your application. So those features, they can tap into the analytics capabilities that are embedded in the InterSystems Iris platform. And when you're then deploying your application to 1, 2, 3, a dozen, 200 different customers, you don't have to worry about deploying and installing a whole set of different features and tools. It's all included in the same platform. It's all in the same box. So that makes your provisioning, your pricing a lot more straightforward. So there's many sessions at this conference about those individual tools and individual features of the platform that are embedded inside the platform. Now, this is for the not so black and white case where you want to gradually extend your application to also include data warehouse-like functionality. What if you are looking at a brand new data warehouse where you're looking at converging data from multiple sources and build your Kimball schema of measures and dimensions from scratch? So, and why would you choose InterSystems Iris from the broad set of platforms that is available out there? This really touches what InterSystems Iris is all about, delivering speed, scale, and security. So we'll touch on speed and scale in just a minute, but security is definitely also something that a lot of new entrants to this market have been glossing over a little too lightly. But it is all the more important if you're thinking about use cases in healthcare or finance, where you obviously don't want to gloss over security requirements and regulatory compliance. For these standalone data warehouses, InterSystems Iris as a platform with offers breadth, offers a couple of integrated analytics components as well. So you've heard in the keynotes how we announced InterSystems Iris Adaptive Analytics as an accelerator for these sorts of use cases. That makes it easy, or that accelerates both the queries as well as the adoption of BI tools by giving you a nice look at the business model that's hosted in that additional layer. We're also offering a partnership with DataRobot that not only at a technical level makes it easy to get your data from InterSystems Iris into your DataRobot environment, but also it gives you access, commercially speaking, to the DataRobot community of customer-facing data scientists who can help you kickstart your data science projects. Okay, let's dive into speed for a little bit. To explain you what kind of speed features there are available in Iris, I did a little local experiment, small isolated experiment. I created a simple sales table with a couple of columns that correspond to typical dimensions, such as last month and south region, so the sales region, and we can then issue this query, this very typical analytical style query, at this table, which I populated with 10 million rows. Gives me a baseline response time of so many seconds. Now, we want to filter this data to only the records for last month and only the records for the south region. So that's probably only going to end me up with 500,000 of the 10 million rows that were in this record, in this table in the first place. So I want to not be reading the whole table, and I want to leverage an index. So many database platforms offer indices, and pretty much all of those platforms are building their index one way or another on a B-tree structure. So that's a very practical structure to maintain, and it helps you get to individual rows very quickly. The problem with B-tree indices is that they start taking up space and that they're also hard to combine. So if you need to not just get the information for the south region, but for south, for last month, for web sales only, and only for a particular promotion. So combining those 4 indices starts adding up both in terms of space and in terms of processing time. So this is where a bitmap index can help a lot. So those are very compact indices, so they take a lot less space, and they're also very easy to combine because you can just add them together using Boolean logic. And then further to save space, you can also parallelize the work across multiple CPU cores to kind of take advantage of the fact that you know that you're having to read a lot. So that is that sort of those broad queries are good candidates for parallelization. So is this unique? Well, there are many database platforms that offer some kind of parallelization, and there's also a few that offer bitmap indices. But what is interesting about InterSystems Iris is that we've developed those from our OLTP heritage. So our bitmap indices, unlike many others on the market, can sustain super high frequency individual row updates. Our parallel query execution engine is based on a work queue manager that was designed to support online transaction applications, so that those big analytical queries, they don't get in the way of your regular application processes. So that's what that kind of plays into that idea that a lot of analysts are announcing that the database market is converging, and there's a small set of leading platforms emerging on top of which you can implement both your OLTP and your OLAP use cases by just using the features that are catering to those, but available in the same technology platform. And that makes your technology environment a lot easier to maintain, of course, if you only have a single platform to cater to. Okay, we've talked about speed with a small local laptop-sized experiment. These numbers also hold if you run them on a larger system. So let's try and look at that and just briefly touch on the scalability portion. So there's 2 axes along which you can scale, and we call those vertical and horizontal. So vertical scalability is all about leveraging all of the hardware resources that the database gets access to. So if you get more CPU, use more processes. If you get more memory, efficiently manage all of that memory. So that's what vertical scalability is all about. And to achieve this, we work very closely together with our hardware partners. When they have new premium hardware that they're about to release, we work with them and test our software on them and make sure that we can kind of squeeze out the last little bit of performance out of those new architectures for our biggest customers. At the other end of the spectrum, we're now offering InterSystems Iris on ARM processors, which means that you can run them on edge hardware and also on those cost-conscious cloud infrastructure options that run on ARM processors. Cloud is especially interesting in the context of vertical scalability because the flexible menu that cloud vendors offer allows you to just pick exactly the size of infrastructure that you need. And if you have a database platform that is efficient in leveraging infrastructure, that kind of immediately translates into cost savings. But of course, you can only grow vertically as big as the biggest server that there is available on the market. And for the typically very large data sets and very broad use cases of a data warehousing environment, you also need to be able to scale out to multiple servers. So that's what horizontal scalability is all about. For this, we offer our ECP, Enterprise Cache Protocol technology, which allows you to scale for user workload. And we also have the ability to shard your data, to split your data across multiple servers, and also distribute data-bound work accordingly. And we allow you to do so independently of one another. So if you have a really big data set with a modest number of customers, or a relatively small data set, but a huge number of customers, we can make sure that you again, get the most bang for your buck, and that you get the most efficient combination of hardware to service that workload. So that was in a nutshell how InterSystems Iris supports these data warehousing use cases. We've talked a bit about speed, about security, about scale. We've talked about packaging and the other analytics capabilities that InterSystems Iris offers. There's a number of other sessions that are related to this topic that you can check out. And of course, you are most welcome to try out the technology itself from our free trial version that you can access from intersystems.com/try. With that, thanks a lot for your time, and hope to see you soon.